Hello, this is Information Service Engineering, lecture number 3, Linked Data Engineering. In this part of the lecture, we are going to see how to represent facts with RDF. And let us start. So the question here is how to represent knowledge. There is so much knowledge available, and we have to find ways to represent the knowledge. But we want to do this representation in an intuitive way. So let's see how can we represent the following fact. We have here the fact which says Pluto has been discovered in 1930. So how can we represent this fact? We can start by splitting the sentence in meaningful parts. So the first part we can have out of this sentence is Pluto. Okay, we have Pluto here, we can say that this is a subject. Then the next part we can have from this sentence is has been discovered in, which means like what happened to Pluto, since Pluto was our first component here. And this is called predicate. And then we have the 1930, the last component from the sentence, which we'll call object. So here we see that we have an intuitive knowledge representation of the sentence we have with a directed graph, since the two components, Pluto and 1930, are connected through the predicate, as we name it, which is the information has been discovered in. And this is exactly the idea behind RDF. RDF is a resource description framework, abbreviated as RDF, which is how you will usually find it with this abbreviation. And this is the notion of RDF, that the knowledge is represented like this, with a subject, a predicate, and an object connected to each other, where the subject here is a URI. The same thing comes with for the predicate, is also a URI, and the object might be a URI or a literal. URI here is an identifier, an ID, which is, it comes from the unique resource identifier. But let's see it a bit in more detail what this actually means. So this is an RDF statement or an RDF triple, as it's also called. So the basic, the building blocks in RDF is the subject, the predicate, and the object or the value. And as we said already, so the object is represented as a URI, the same for the property, while the object can be a URI or a literal. But what this URI means, so you see here that instead of having Pluto, just the word itself, we have something which looks like a URL, which starts with http :/dppedia.org/resource/Pluto. So this is how a URI looks like. It's an identifier for this entity, for this word, Pluto. And the same happened here for the property itself. So now we don't have any more, so it is discovered in, but only an identifier for it, which is a URI, again, starting in the same way, dppedia.org/ontology this time, /discovered. And for the 1930, so for the date, you see that we don't have similar behaviors here, so we don't have a URI, but a literal. So this is a literal or a value, since it's a real value, only the value of the date in quotation marks. So this is the graph representation of the triple or the RDF statement we have already seen. The same thing can also be represented in another way. So here we have exactly the same knowledge as you see encoded, but this is a different way of representing it. So this is in an n triples serialization of exactly the same knowledge we have with the graph representation. But let's see, can we have some more information about Pluto? For the moment, we know that Pluto was discovered in 1930. What other knowledge can we have here? So we can have the information of who discovered Pluto, so who was the discoverer, which is again connected to Pluto. So one more fact here, one more RDF triple. And then can we know something about this person? Yeah, we actually know the birth date, which was somewhere in 1906, and the birthplace, which is a city somewhere in Illinois. And any other information here? Yeah, actually we have something related to this street or city of Illinois, which is the motto of the city. So you see how rich can be this model, and how can we represent actually a lot of knowledge and information through this model by connecting the information as a directed graph here. So we've seen, we are talking about RDF, the Resource Description Framework. So RDF is a triple model. Every piece of knowledge is broken into a triple, which consists of a subject, a predicate, and an object. But also RDF is a graph model, where every piece of knowledge is interpreted as a vertex, edge, and a vertex. So here the subject and the properties, the object are vertexes, and they are connected through an edge, which is the predicate. And let's see here some RDF triples and try to analyze them. So we see that we have several RDF triples. In the blue color we have the subjects, in the red one we have the properties, and green are the objects. And let's go deeper. So here in the black color we have the so-called individuals or entities. So these are entities of actual real-world entities. For example, Pluto is a real-world entity, so that's why there is an entity for this planet with a unique identifier. Also, the person who discovered Pluto is a real-world entity, and we have again an entity, an individual, to describe it, as well as for the specific city in Illinois. And then we have the classes. For example, place is a class, or celestial body is also a class. So what is a class? Is a way to classify or group things, entities in our case here, where they have the same characteristics, they share the same characteristics. So for example, many cities like Illinois are grouped into a place. They are part of they are a place. Or the same happens with planets like Pluto, so they are celestial bodies. And then we have the literals. The literals, or the values, as we saw before, where here 1930 is a literal, which means it's a real value, or the birth date of the person is a literal. Or another float value that we have here, the longitude and latitude, they are also literals, meaning real values, not entities. You see that we don't have an identifier for them, but only the information itself, the value itself, into quotation marks. And then we have the properties, which actually connect two entities, or an entity and a literal. So they state between two entities, or an entity and a literal. And then we have the vocabularies or ontologies. So you see that there is these URIs actually that we use, they are not just some random identifiers. You see we have some repetitive patterns, and that means that there is a vocabulary behind it. So we actually use this information, the URI of Pluto, which is defined in some vocabulary or ontology. So in this case, Pluto comes from the Wikipedia ontology, as the same thing happens from the discoverer property, for example. So it comes from the Wikipedia ontology too, while the place class is defined in schema.org. And let's see now what is the difference, the actual difference between the URIs and the literals. So URIs reference resources uniquely, so they are unique identifiers to resources, while literals describe data values that they don't have a separate existence. So here, for example, in the pink circle we have a literal, which is a value that has no separate existence, it's the 1930, while in the blue one we have a URI. It is an entity identified by this URI, this unique resource identifier. And let's move now to the, let's go a bit deeper for the literals. So the literals can be typed literals and expressed by the XML schema data types, which you can see in the right part of the slide. So the namespace here for the typed literals is the following, so http://w3.org/2001/XML schema. So it comes always before. This is the namespace of the typed literals. And let's see some examples about that. So semantics is a literal value. It's actually a string. So you see that after the value semantics in quotation marks, it comes the whole definition of the data type in which it belongs. So here we see that semantics is a string, while the next one is a float. And the last one, the 215 of August 2nd, is a date. But apart from typed literals, we also have extra information that we can provide about literals. And these are the language tags, which denote the natural language of the text, actually. So, for example, the first one here is semantic, with K in the end, at D. So this means that comes from the German language, while the second one, the semantics at EN, this is in English. And let's check now the blank notes. So the blank notes denote the existence of an individual which has specific attributes, but without providing an identification or reference for this node. So you see that this node has nothing inside, has no identifier or value inside. So because of that, cannot be referenced externally from an external source. So we cannot really refer to it anymore, but we will see in the future that they play important roles for some specific tasks. And here we see how many different serializations or formats we have for RDF. So we have the N triples, the RDF XML, the JSON, Turtle, 3G, N-Words, RDFA, and many more. First they were the N triples and the RDF XML, and then the N triples extended. They were extended into the Turtle format, and then to the Tri-G. So the ones on the right, so JSON, LD, Tri-G, and N-Quads, they are the models that support multiple graphs. So in the course of this lecture, the examples that we will be presenting will be in this format, in the RDF Turtle format. And in the next part of the lecture, we will actually go deeper and check how does it look, this RDF Turtle serialization format.